Hip hop is liked most, according to this data.
According to this data.
Right.
All right. And then now let's look now. So hip hop is liked most. All right, fine. Then we see that dancehall
comes next.
So dancehall would be more than reggae, more than R&B,
but less than hip hop.
Less than hip hop. Can we say anything else? Because Sambod and Sage still want to gather some more information.
Well, we confirm that they used 40 students because hip-hop is 20, R&B looks like 6 there, and dancehall is 10, and reggae is 4. So if you were to add 4 and 10, that's 14, 14 and 6, that's 20, and 20 and 20, that's 40. So the data tells us some things. It tells us that all the members of the class were surveyed.
Yes, that's true. So this would be a good data because everyone responded.
Yes.
All right. Or more than 50%.
There you go. 100% respond in this case.
Yes, yes.
All right.
But was Sage correct in her assumption?
No.
Boy, I sorry for Sage.
So you see, assumptions are not necessary when you're dealing with statistics. Use the evidence that you have. Look at the statistical data, then you make inferences and conclusion. Assumptions don't count here.
Not at all. And lastly, there's another grade 11 class, 11-1. Can Sage make an assumption on the favorite genre for both
What I tell you about this assumption thing?
Well, she has the data for her class, so what you talking about?
There you go, it's for her class. So she cannot make any assumption for another class.
But hold on.
This data set is only for the class that she has surveyed.
But it's the same grade 11 stream.
But it's different kids. I can't take your data from your family and say, okay, if your neighbor are gonna like the same thing that you like. So, no, I can't.
All right, you have a point.
So I can't use this set of data and throw it on another class.
All right, you have a point.
Assumptions are not needed in statistics. We will only look at the statistical data given. That's something that we need to remember. Pay attention to the data set that you are working with.
All right.
Yes.
Let's take a look now at Mrs. Baker's class.
Right.
Mrs. Baker gave her grade 8 class a mathematics test in November and recorded the scores obtained by students to the nearest percentage in the table below, and we're seeing our table.
Right.
She wants to know from the table given which of the following statements is most likely to be true in order to make adjustments for the end of term test they will do in December. So we're looking at our table.
So which is most likely to be true?
Most likely. So A, the model class is 41, between the class 41 to 60. B, more than half the number of students scored over 50% on the test.
All right.
So remember now, we're using our table. And we need to know, draw some conclusions, draw inferences from our table.
And see which one is it, A or B.
Nice. And
I'm going to start with B
likely
to see if, you know, I like to work like that sometimes. So more than half the number of students scored over 50% on the test. Okay, so 50% would start in the class 41 to 60.
That's our third class.
Right. No, my issue is why I can't tell you yes or no. Although there are 8 students in that class, I really don't know what their scores were. They could have gotten 42. All of them could have gotten 42 or 43.
But 50% is within the class.
Yeah, but I don't know how many of them got 50, so I can't tell you. I can't tell you how many out of that class got over 50%. So you know what happened? I'm going to choose B. Let me look at A and C.
So for B, then you're saying you can't choose, you can't say B. So you can't say more than half the number of students scored over 50% on the test.
No, because that class, there's no conclusive evidence for that class. You know, I can't, because everyone could have gotten below 50 and they could all have gotten above 50, but I don't know. I would have to look at individual scores. I'd have to bring out the raw data.
All right, and for A now, so you're correct for that one, you know. You're correct for that one, but for A now, the model class is 41 to 60.
All right,
now we're still looking at the third class?
Model class. So when you talk about model class, you're talking about this class would have the highest frequency.
Which is correct.
Which is 8. So yes, so A is correct.
But hold on, man, model class? I am sure I heard the word or the term modal class and modal score. They sound very similar.
They have something similar. There's mode in there. but they're two different values.
Oh, they spell differently, score and class.
There you go. Well, you think? Score, class? Right. So the modal class has to do with the class with the highest frequency, while the modal score is the actual value, that single value that appears most frequent within the set of data. Now, the modal score, looking at this particular representation, I can't determine it just by looking at it.
Even though it has the most frequency?
No. Yes, but guess what happened? As I said before, what if everyone in that class got a different score? So I have 8 scores in that class, but they all are different scores. That means the modal score is not in that class. It could mean that, let us look at the second class, the 21 to 40. What if all 5 of those persons got the same 40?
Which means that would have been our modal score.
That would have been our modal score.
Oh.
But it is not a part of the modal class because the frequency is less.
Modal score,
Modal class. So let us just tie that up. The modal class is the class with the highest frequency.
Yes.
Right? While the modal score is the actual score, the actual data that appears most within the set of data.
I get it.
Okay.
I understand.
All right.
Clearer now. Very much clearer. All right, let's take a look at, remember we're still on statistical diagrams and we're still looking at statistics.
And here we go with another one.
Still making inferences from our raw data.
And no
tables,
assumptions.
charts, all these we're doing. So let's look here. So Lee and her friend Cami are members of the Girls Scout. They are selling cookies but realize that some days it seems like they are doing well, but some days it's not so well. Cami, being analytical, decided to record cookies sold daily and represent it on a suitable graph. What do you think they can gather from the data?
Well, I like this line graph because one, it's very simple and I can pretty much see that Friday is a good day. Friday cookies sell. I can just look at it and see because I would have seen the number of cookies on my, as you had pointed out, my vertical axis,
yes.
which is my y-axis there. And on my horizontal axis, my x-axis, I have the days of the week. So I'm selling cookies Monday, Tuesday, Wednesday, Thursday, Friday. Friday is the highest point. So I know that Friday, I want to sell cookies on a Friday.
I would sell cookies on a Friday because school finish on a Friday,
Well, that too.
So every money that you save during that week,
spend on a Friday.
I'm going to spend it on cookies.
I'm not selling no cookie on a Monday.
Why not a Monday, man?
Monday, nothing much is going on for Monday. According to this data, Monday is the worst day.
Monday is the worst days?
Yes,
Let me see. Oh, Monday is how many? 20 cookies?
20 cookies is sold.
All right, 20 cookies on a Monday. Let's go to a Tuesday.
30.
Approximately 33. Yeah, 30. All right, so Tuesday is better than Monday.
Good. Yeah, I can start on a Tuesday.
But still not good like Friday.
No, Wednesday good too.
Wednesday, yes. Look there, you don't see the trend,
Wednesday's
the pattern
45
taking place.
cookies. Wednesdays is a good day.
Wednesday, so
Thursday I can't stay it. I don't need to sell cookie on a Thursday.
you don't, but Thursday is more
It's
than
more than
Monday.
Yes, it is. But, so if I was to choose 3 days to sell cookie, I would go with Tuesday, Wednesday, Friday. If I was to choose one day, it would be Friday.
But guess what? No. So Monday, Tuesday, Friday. Those are the days you would sell.
If it's 3 days, I'm selling cookies.
3 days. But in looking at this line graph too, I think this was a good way for Cami to have represented it.
I think so too. It's easily understood.
It is, and remember, she said that she knows that they were doing well some days, and some days they weren't doing well.
So guess what? Patterns occurring so that they know. So when you have a line graph, you can see the patterns that occur within the line graph. So she can pretty much see that if she's selling cookie every week, there are certain days that she should really and truly carry more cookie.
And she can also see here from the line graph that, hey, there's an increase from Monday to Wednesday.
Therefore.
And then there's a decrease.
I wonder what would have caused the decrease on Thursday though. You get enough cookie Wednesday, seeing about a one on Thursday?
Maybe, maybe. It could be. We're not sure.
Exactly. So that's another set of statistical data we need to collect.
We can't even assume
no
right
assumption
here.
No assumption.
Not at all. All right. So we're all right with Cami and we're all right with Lee because they know now, all right, these are what is happening. We're looking at the patterns. We're looking at the trend right here. Which days are the best days then to sell cookies on? Which days are not so good? So they're able now to pinpoint and to make a decision, as we would have said earlier. What are the best days to sell cookies?
So pretty much.
What are the best days not to sell
There
cookies?
you go.
So we have best days to sell and best days not to sell.
I'll tell you. So we can pretty much say that, you know, when we use a line graph, it helps us to identify patterns easily. We also are able to see trends much easier than if we were looking at a pie chart, right? So yes, some data set, a line graph is perfect.
Line graphs, all right. But for those who would have missed the first section,
just joining us.
So what we have been looking at, we're just recapping what we would have been doing from we started to now. So we're looking at the importance of statistics to mathematically describe or depict finding. We're also trying to draw conclusions from findings. And we looked at some examples of statistical diagrams thus far. We looked at a pie chart, we looked at bar graph, we looked at line graph as well.
And the table.
We looked, oh yes, we looked at that table.
With the class and the modal class and the modal score. Yes, we did.
We looked at the table, So let's see if they have been following, because some may have started after
we looked at
some stuff. So guess what?
Let's look at another scenario.
So Asher and his friends want to have a movie night with their classmates, but they don't know the type of movie to play, since each person has a favorite type. Alistair told Asher he believes they should gather the data from their friends and make a decision at that time.
That makes sense. I like Asher's style. Yeah, man, you have to, it's Alistair. It's Alistair.
Yo, it's
Alistair
not
told
Asher.
Asher. Right, so Alistair is on the right track. Let's not assume anything. Let's gather some information.
And in gathering the data too, it's so good that with gathering this data, they're not only using what they like, Alistair and Asher, but they're looking at their classmates.
Exactly. So
because it's going to benefit their classmates.
Exactly. So they're trying to choose the best fit type of movie to watch.
The favorite type of movie to watch. So let's take a look here.
So they collected their data.
Collected the data.
And this is what? Bar chart. So they have presented the data on a bar chart. So let's see what movies they have in mind. So they have comedy, action, romantic, drama, and sci-fi. Now, according to this, what would be the best choice?
Boy, I would say romance, you know, because romance is way up there.
There you
so
go.
I would say romance. I wouldn't even look on drama.
Drama not going to play.
No, sir, drama not going anywhere. But I think Alistair wants to know how many friends they interviewed in order to make a decision. But why do you think he want to make this decision now?
Well, maybe he's looking at other things, because if he's looking at the number of persons that they would have interviewed, he probably would know what space to use. If he's at school, what room to decide to use.
Can't be at school right now.
Well, that is true. So if he is using a personal space, or he wants to make sure he is socially distancing,
yes,
he may need to decide what size room he's going to use. And if he's catering to them with popcorns or stuff, he needs to know the number of persons that are coming. So let us see what we could use to help him do that.
So this information is important.
Oh, yes, it is.
Yeah, man, it's important.
So according to you have four shows comedy.
Okay.
We had 5 for action, so that's 9 already. 6 for romance.
That's 15.
There you go. And 1 for drama. And 4 for sci-fi.
20.
So 20 persons. So he needs a space that can hold 20 persons with proper social distancing.
And enough popcorn.
And enough popcorn. Each of them have to get their own, because we're not sharing at least. There's no sharing.
Even if they don't get their own, we can maybe share it,
well,
you know.
20
so we'll not share it. Yes, 20
content.
But 20, including both of them, man.
Oh, yeah.
Alistair, why
So
are you leaving out Alistair and Asher, 22, man?
Right.
Because they were not a part of this data that was collected.
No, because they would already know what they liked.
Yes, nice.
So what we're saying, when you have a data set or representation of statistical evidence, there are several things you can get from it. So although they just were looking at initially the type of movie that they wanted to watch, from the data that they collected, they could also determine how many persons would partake in this movie watching. All right.
They could. I think they have another question. How can Asher and Alistair know the type of movie most friends like? We already know.
We
already
did tell
talk
them.
about
We
that.
tell them already. So.
Romance, don't it?
Right.
And let's see now. What if Asher could not find a romantic movie? What would be the next favorite type of movie?
Well, according to the data, we
That's
look
what
at
I was going to say,
Yes.
because what if Asher no want to say, boy,
You might go watch drama.
drama?
No.
What a pricky that would
No,
be.
them would have upset.
Very upset.
Right. So they would have to look at the next highest data set, and that would have been
Sci-fi.
No, miss.
Of
5.
course, sci-fi and comedy tie.
Yes,
the tie
but-
for 4.
But action win them. Action
I
get
know,
5.
but still, look on comedy and look at sci-fi.
All right.
Comedy is 4, sci-fi is 4. That
Good
means
observation.
8 of them vote for comedy and sci-fi.
So we're going to get a comedy sci-fi movie.
I'm sure we can find one.
Well, if it's a comedy sci-fi, sure, but that's not how we read the data, though. We read the next set of data. So we have 6 persons who would have chosen romance. The next data set, which is closest to it, would be 5. So it would be an action movie, miss. However,
Fine. You
if
win.
it's comedy or sci-fi, either one can play.
Fine, you
Okay.
won. So we saw that there was some tying coming in here too, that hey, some chose comedy, the same number chose comedy, chose sci-fi.
Yes.
Doesn't mean it's
It
it's
doesn't
not
mean
the
that you
same,
can
you know.
combine. You can combine it to give you a higher data.
Well,
set.
maybe we could combine romance and action.
Well, yes, you could. It would be 11, don't it?
Yes.
No,
it
we're
could
not
be.
going to do that. We're looking at one particular type of movie. So we would have to look at the data set by itself.
All right, so it's
Great.
romance. All right,
All right.
fine. And our final scenario
There you go.
for session today, you know. During an election for student council president, Mark was the clear favorite to win. Anthony pulled out of the election due to personal reasons. Mark lost the election to Simone. He blamed his loss on the fact that Anthony pulled out of the election. Could this be true? Provide reasons to support your answer. Boy,
All right.
me no blame Mark, you know, me no blame Mark.
So you believe that Mark has justifiable reason to say that is because of Anthony pullout? Well, guess what happened? With this information as is, it's not sufficient. It's just pure assumptions. So once again, without what
Data.
again? Without data, without sufficient statistical data, no conclusion can be made, no inference should be made. We really should get data on this because we don't know why Mark
We
was
don't
not
know.
victorious here.
Maybe they voted
So-
for Simone.
Right, because
they like Simone more than Mark.
There you go. So we can't assume anything.
We can't. And guys, that's it for today's lesson.